Hi, and welcome to the second video in this NXE tutorial series. I'm Rob Rigler, and in this video I'm going to be looking at the basic programming of the NXE robot and using NxEditor and its simulator. In the previous video I detailed how to install and set up the NxEditor itself, so please watch that video if you haven't already. Let's get started by opening NxEditor and creating a new file. This is done by clicking File in the top left corner and then pressing New. Once you've done that, the text editor window itself should become selectable and we can start writing our code. But before we get into that, let's look at the makeup of our robot. On the top toolbar, go to NXE Simulator and then Open NXE Simulator. You should now be presented with another window. At the top you'll see various buttons such as Robot, Background and Sensor. Go to Robot and then Edit Robot. Here we can see the general layout of our robot, dimensions, components and interface. The most important thing to look at here, which we'll be using this lesson, are the ports left wheel and right wheel, set to output A for the left wheel and output C for the right wheel. These are the default values for the left and right wheel, and I suggest you keep them that way because this is how we'll be using them in this lesson. Next we can look at our components tab, and we can see that we've got 4 individual sensors attached to the robot. We won't be looking at those this lesson, but we will be in future lessons. Now we've had a look at our robot, let's get to the programming. If we exit out of the simulator window and click on the editor, type the following. Task main, curly brackets, on FWD, out underscore AC, comma 50, semicolon, weight 2000, off out AC, not forgetting the brackets and the semicolon, on rev, out underscore A, comma 75, semicolon, weight 1000, and off out underscore AC. Okay, I'll be going through what that means in a second, but for now, press build and save. Save the file as anything as long as it ends with the .nxe file extension. And the compiler will return any errors in your program. For me, it returned no errors, but if you do get some, it'll give you an accurate message of what is wrong. Normally it's a missing semicolon or a comma, or it could be a missing capital letter. Make sure all of this is typed exactly how I typed it here. Press OK, and then the Start Simulation button. Wait for it to load. And there we have it, a moving robot. We can press the Start Program to run our program again. We can go to Start Position to reset the robot. You can also click the Draw Marks button here, which will draw a red line on the floor for where our robot has travelled, like so. If we press the Start Program, we can see that our robot moves forward for 2 seconds and then reverses to the right for 1 second. Let's have a look at the code to see why it does this. Exit out of the NXE simulator. Let's have a look at the code. On line 1, we have task main. NXE, like other C-based languages, requires a main function. This is the function that is always executed first, and if task main does not exist, then none of your code will run. Lines 2 and 10 are the curly braces of the main function. They encase all of the instructions in the main function and are required for other tasks and control statements. Looking on line 3, we've got the statement on forward, out AC, 50. What this does is instruct the outputs A and C to move forward at 50% speed. If you can remember from before, the ports A and C are our left wheel and right wheel respectively. So this command makes our robot move forward in a straight line at 50% speed. Similarly, on line 6 we have on rev, out A, 75. This time we are only using output A and instructing it to reverse at 75 speed instead of both wheels going forward at 50% speed. This command instructs the robot to make a backward turn. On lines 4 and 7 we can see the wait instruction. This is a simple statement that tells the compiler to wait for the time specified before going on to the next statement. This allows for the forward and reverse commands to continue for the time specified. If we remove the wait commands from the simulation, we can see that the robot does nothing at all. This is because the program ended immediately after turning the motor on. On line 5 we have the statement off, out, AC. This statement completely stops the power to the specified components, A and C, which are the wheels. This command is important because programs only do what you tell them to do. In the lines above we've instructed both of the motors to move forward, but we haven't told them to stop. So the robot will keep on moving forward unless the program stops or a different command is given to the motors. So when we get onto the on rev on line 6, motor C would still be moving forward if we had not instructed it to turn off on the previous line.